Welcome to MEEE 316, Mechatronics and Measurements Laboratory. I'm the professor for this course, and my name is Dr. Rico Piccone. I think many of you know me because this is a concurrent and prerequisite enrollment course. You must be enrolled or have been enrolled in ME 315 and ME 345. So, if you haven't, let me know or talk to your TA about what's going on. In any case, I'm going to walk through the syllabus in this lecture. It's not really a lecture. I'm just walking us through the syllabus, getting you oriented in the course, trying to set you up to succeed in this course. So, yeah, go from there. It's a laboratory course, and nominally it meets once a week, but we're going to have several weeks that have no lab and no meeting. So we'll talk more about the schedule a little later on. So the idea of this lab is to introduce you to several different types of instrumentation and electronics, and it's a companion with both the Mechatronics course, ME 345 or EE 345, and also the Measurement, Instrumentation, and Experimental Design course, ME 315. So you're going to get a little bit of a mixture of concepts from mechatronics and concepts from instrumentation and experimental design. So a little bit of everything in this course from that area. They're very closely related, and that's why we sort of combine them in this lab. So we'll talk about, or not just talk about, we'll actually get some experience with DC and AC circuits, filters, power supplies, function generators, all kinds of measuring devices and signal generating devices. Microprocessor boards. We'll specifically be using the MyRio microprocessor boards. Analog and digital signals, sensors, Wheatstone bridges, AC to DC power conversion, real-time measurement, time response, LabVIEW, programming, and DC motors. So, lots to do in this semester. And general information, here are my office hours, office location. The lab is in the Panowitz Hall building, 107, the robotics lab. Should be there right now, so that's good. You found it. Congratulations. Times. Tuesday, Thursday, and Friday are the 3 sections. You're going to have to keep going to the section that you are signed up for due to the constraints we have with the number of students in these labs. So continue to go to your lab, and then also you have to continue with the group that you get with it this first day. So you heard it here, and you're going to be organizing yourselves into groups soon. So definitely start thinking about who you would like to be in a group with. Moodle. So there'll be a Moodle for this. It's not up yet, but you'll be able to see your grades on there. Your TA will be expanding on further whether or not you'll be submitting your lab reports there on Moodle. That's something that is still in limbo at this point, so we might be able to do that on Moodle. Otherwise, we're going to be doing paper turning in of reports. So we'll talk more about that in a bit. Laboratory manual. So if you click this link, it opens up this page, which is the Mechatronics and Measurement Lab Manual. So this is brand new / continuously being created by me. It's not something that you're going to want to go print out the entirety of right now because it's very much evolving. So before, I would say, you probably want to wait until your laboratory section or right before your laboratory section to print out, if you choose to print out the lab exercise for that week. So it'll also be available online all the time, so you might, since all of the lab stations have a computer, you might just open it up on the computer. You can open up one file that's got the entire lab manual, which, you know, there's 59 pages right now, but it will get bigger. And also the individual, not really lecture, but lab exercise files. So lecture 1, or chapter 1 is associated with the first lab. There's some lab exercise, and then there's some resources that come along in that chapter. And then there will be the lab exercise 2 is in chapter 2. There'll be lab exercise, and then there might be some resources that come along there. So that's sort of the structure of the lab manual. We'll talk a little bit about, so I'm not going to get into the details right now, but if you click on each of these, so lab exercise 1, you can see the first lab exercise, a standalone PDF of that. So you could use that to print it out or whatever you choose. Okay, so that's the lab manual. You'll be using that. You and your group will be going to stations for most of these labs and working on the working your way through the lab manual, the lab exercise together, and then working together on the report afterwards. So it's the general structure there. So back to the syllabus, laboratory manual covered, and the schedule. This is tentative. We might move things around a little bit, so don't plan trips around this, please. I'm going to try to also include another lab in addition to these. So there are 8 on this schedule. There will probably be a 9th. I haven't figured out which week that's going to be yet, so at least 1 week's going to change in here, probably more. So we are on Lab 1, Introduction, Report Writing, and Equipment. So I'm going to give you a separate little video for that, but in any case, something to look forward to. And then next week we'll do another lab, Lab 2. These first 2 are really a lot of orientation, so you're not doing too much besides getting yourself oriented and getting your report writing tools ready to go and getting an understanding of how things are going to work in the lab. So that's what we're doing now. Okay. We'll move on, do some circuit response measurements. We'll do a bridge rectifier lab, AC to DC conversion. We'll measure a thermal response in lab 6, which is a fully calibrated response, pretty involved. These labs that are later on, they get more involved. So the first couple are pretty easy, and then they get progressively more difficult. So yeah, but like lab 6 and lab 7 are both very involved. Lab 8 is going to be amazing. I haven't yet designed it, but I have some ideas. It's going to be cool. So that's going to be a new one this year. And probably one more additional one, which will be more practical, building a circuit that's not in a breadboard. So soldering things and wires and whatnot. Practical stuff that you'll be able to use for your senior design projects. And in fact, that's a good note. A lot of this stuff that you're going to learn can be very helpful for your senior design projects. A lot of what I teach, it's kind of funny, a lot of what I change in what I teach, I guess, is in response to repeated questions I get from seniors. About how do you do this? How do you make this motor work? How do you sense this quantity? And so I try to incorporate more and more of that stuff that I see a lot coming from senior design projects into these lower level classes so that you guys have the tools that you need to do your senior design and be successful. So in any case. Okay, resources, there are a few that are going to be, I probably will just list them here, but I put a little separate page. The article using the first lab is here, but there will also be a link in the lab manual to that. And some general resources that are useful: Art of Electronics, All About Circuits Online Text is pretty nice. And then some writing resources. We're going to talk a lot about writing in a few minutes. So yeah, those you might find useful. I encourage you to take a look and maybe become very familiar with those. Lab policies. So a lab report will be due the day before the next laboratory exercise. These laboratories reports will be submitted via Moodle, probably, hopefully. It must be formatted with the LaTeX template provided on Overleaf here. So if you click this, you're going to get this to pop up. You may or may not have an Overleaf account. It's a website that allows you to do LaTeX collaboratively with your group. Okay, so LaTeX is a document preparation system. I'm going to have a whole resource about it in the lab manual, so it's something to, we'll revisit shortly. And the this website is great. So you don't have to learn how to install LaTeX locally on your machine, but so you'll be able to do it all on the web browser. So this is really nice, and you can live collaboratively edit with your group. So when you come here, clone this project, and you'll have to sign up. It's free as long as you don't use too much space, and you shouldn't for this class need to. And yeah, so sign up, and then you can use this really great tool to prepare your lab reports. Now, speaking of this, there is a lot of stuff in this template, and it's not there just for fun. It's all virtually all that's going to need to be deleted when you write your first lab report. But it is also a guide to what content should be in each section. So it has sections already listed out, and it has this nice MIT's guidelines for writing a lab report. Quotes in here as just general what should be in an introduction and a lab report, and then I also give my little guidance too. So something to read through and notice one section's author contributions. Every lab report you're going to need to say who did what on the exercise and the report preparation. So there's there can't be people just freeloading on the group. That can't happen as long as you guys are being honest, which I expect. So great. This appendix is another little LaTeX tutorial that has, so if I click on this, it'll go to this. So it'll show you the source here of how to do different things, like how to typeset equations and matrices. And this is the output that comes out in a nice PDF. So it's really cool. LaTeX is amazing, and it if you buy in, it will be your friend. So buy in, and you can have a new friend. So it's great. All your figures and whatnot can be included in here in your tables. So yeah, this is what you have to use for your report preparation. In my old age, I'm becoming a lot more authoritarian. I feel like it's a theme this semester. Okay, so where was I? So that was the lab report template. Great, and there'll be more discussion of that in the LaTeX tutorial. Procedures should be performed in the assigned groups, and these groups should submit a single report. The report must be the product of every member of the group, and there must be a section of the report that describes each team member's contribution. That's important. It's not there, you guys don't get a grade on the report. So it's got to be there, and it's got to be, it has to actually describe what people did. And if it doesn't have anything substantial, like the person helped with the lab exercise, that person will be receiving less of a grade for that. So keep that in mind. You need to contribute, and you also need to describe what was contributed. Okay, grading policies. Lab reports, 100%. So they have to be good. Okay, so that's the idea. This is the breakdown of how they're going to be graded. So lab exercise execution is 30% of the grade. So how well did you execute the lab exercise as described? Did you get reasonable results? Could you describe the steps properly in your own words? And then do you demonstrate an understanding of the experiment and the results that you got? That's 30%. 30% is theoretical analysis. So most of the lab exercises include an aspect where you're going to have to predict theoretically the results that you get. So the data that you get, you'll often need to plot, and the plots will have a theoretical curve on them, and that's what this theoretical analysis portion is going to be focused on. And they're also going to include the data. So yeah, theoretical analysis 30%. Presentation 10%. So how effective your figures are at describing what was done in the lab report or in the lab exercise, the results that you got. Can you read everything well? Were good scalings chosen? Is it clear? Captions should be able to describe the entirety of the results in a sort of simplified way. So you don't necessarily need to read the entire body of the text to know what each figure means. Each figure should have a standalone description in the caption. Equations as well. They're nicely formatted. You have to buy in a little bit to the learning how to type things out in LaTeX. It's a little bit of a learning curve, but it's really not too bad. And in the end, it's way better than writing it in like Word, for instance, for equations. So, okay, writing 30%. So a significant portion of your grade depends on writing quality. This is, some of you are already pissed. You're like, this sucks. But yeah, it's the way it is. So this includes overall narrative flow of the document, grammar, clarity, and style. This is taken very seriously because it doesn't matter how great your design, analysis, or experiment is, if you can't communicate your results effectively, nobody cares. It's really true. You can't convince people that what you did is good or that they should care about it at all if you can't communicate it to them. So written reports are the primary way that we communicate things in engineering. We can also do oral presentations, but I would say more frequently we're writing reports. So you got to be able to write reports. And it's one of the biggest things that people complain about in terms of engineering graduates, not being able to write or communicate effectively. So heavy emphasis on this. 30% of your grade, that's 3 letter grades, okay? So A, B, C, this can be the best you're hoping for if you're not investing in the writing portion. So, potential grade boost. The weight of your grade, depending on report writing, is significant. I strongly encourage you to go to the Writing Center early on to get help with this. The Writing Center, there's a link. Wonderful. I actually know her. That's cool. Yeah, and it's got all kinds of good information on here. The one thing that I really want you to pay attention to is this peer reading, okay? Peer reading is what I'm going to encourage you guys to go get help through. So the peer reading program. So, and I'm gonna give you guys something to do it too. I recognize that for many of you, writing is a significant challenge. In order to foster the development of your writing skills, and not just say, oh, you suck at writing, so you get a bad grade. For each appointment, up to 2 appointments, with a peer reader in the Writing Center, your grade on the relevant report can increase by as much as 10 percentage points. That is, up to 20 of the total 30 percentage points on each assignment can be granted by thorough engagement with peer readers on 2 occasions for the relevant lab report. Note that the 10 points for a visit is not guaranteed. The peer reader will give you feedback on a form, which you'll need to turn in with your lab report. It must demonstrate thorough engagement in order to get the full 10 points. So if you weren't prepared, if you didn't come and you had to leave early, these sorts of things can make the person grading give you fewer points than 10. So thorough engagement with the peer reader gets you a full 10 points, which is significant. And this way you get credit for working hard to improve your writing. So you don't necessarily have to be a great writer to get a good writing grade on these reports. You can get 20 out of the 30 points just by working hard. Okay, the last 10 points, you gotta be able to write a little bit to be able to get those 10. If you can get 10 points through your writing, and you can get 20 points through working hard, you can get the full writing grade. Okay, so that's the idea there. A little note on that, just how we have to do things because of the way they're set up down there. So you have to have 2 people from your group go to each writing group session. You must rotate through each member of your group equally to get credit. So you can't do just 1 of you, you can't do 3 or 4 of you, exactly 2. An audit will be performed at the end of the term, so even if you have received credit for 1 lab or 2 labs or whatever, for doing this, it can be taken away if members don't rotate. So you can't just have like the 2 of you who are going to be the people who write, and everybody else is going to focus on the experiment or something. You all have to do it. You all have to go, and it has to be equal or as close to equal as possible, given the number of times you do it. So yeah, it's very important. I can't emphasize the writing enough. As you can see, I'm going to great lengths to make it possible for you to improve your writing. Okay, as usual, don't cheat. You'll get an F. Don't copy. Don't take each other's data. You think it's maybe easy to copy things like getting somebody else's data from them and submitting it. It's actually really easy to recognize when there's like the graph is pretty easy to say, oh wow, that's the same exact data point, that's weird, and then you pull it back and sure enough. There aren't that many reports to look at in a given week, so don't just take each other's data and use it. That's considered cheating, and you'll fail the whole class. So bad. Okay, Slack. As with all my courses, there's a Slack group. Join it. Click that link, Dr. Rico. If you're already in it for another class, it's the same one. Just sign up for the or subscribe to the channels 316 General and Labs. And then the last bit is for ABET. So if you're curious, you can check that out. And that's the intro. Okay, that's it. Have a good class.